In case you're just joining us, welcome to class. Welcome from all over. Okay, so welcome to class. Welcome to GER Hub. In today's class, we shall be quick and fast with our discussion. We are looking at a new topic and we shall be looking at indices. So, indices is our topic. Okay, so quickly, I'm going to start with a definition. Okay, so I'm going to start with answering the question, what is indices? Okay, so that's where I'm going to begin from. Now it is best we start from this point because some students may not know what we do in indices as a topic in mathematics. So indices, I'm going to tell you, is a topic in mathematics. It's a topic in mathematics that deals with the laws governing numbers in index form. It deals with the laws governing numbers in index form and the application of such laws. And the application of such laws to real life problems. Okay, so in indices, we deal with the as a topic in mathematics, of course, we deal with the laws governing numbers in what we call index forms and the application of such laws to real life problems. Okay, so that is what indices basically is all about, coming from one angle. However, now that we know that indices deals with the laws governing numbers in index forms, please take note of this number, or take note of this word, index forms. So the question now is, based on this definition, what or when is a number said to be in index form? When is a number said to be in index form? If indices is a topic in mathematics that studies numbers in index, the laws governing numbers in index forms and the application of such laws, the question is, when is a number said to be in index forms? So I'm going to tell you in this manner. Now let y be a number. Let's say y is a number. Okay, now let y be a number, then y is said to be in index form if y can be expressed. Y as a number is said to be in index form if y can be expressed as Charlie Okon. Good evening, welcome to class. Thank you very much. Please help us share this video to all those and invite people to class. Thank you very much. So y is said to be in index form. Okora Joseph, well done. Thank you very much. Welcome to class. Please help me share this particular link to your colleagues. Well done. Welcome. So if y is a number, then we say that y is a number in index form if y can be expressed as y equals a raised to the power of x, for instance. So if you can express y as a raised to the power of x, then we say that this number y is in index form. Now please take note of one thing, that when a number y is expressed in index form, the number a is called a base. When you express a number y in index form, it means that you are to write the number as a base a carrying what we call a power or index or exponent or logarithm. Okay, now whereas this number here, the number A has the name base, the number X can answer any of these four names. It means that we can call this number X power. If you don't want to call the number X power, you can call it index. If you don't want to call the number X index, you can call it exponent. If you don't want to call the number exponent, you can call it logarithm, as you would come to see in my next topic just after indices. Okay, so a number y is said to be in exponential form provided we can write it as a base raised to a power. Now, how do we read this number? If we can write y in this form, we read it as a raised to the power of x, or a raised to the exponent x, or a raised to the logarithm x. Okay, so those are different ways to read that expression. Now, that being said, let's go over it quickly before we proceed. For those of you just joining, we are discussing indices, from which we'll go to logarithms and then sorts. Now, please take note. We have answered the question indices. Just in case you are a student doing indices right now in any course, please take note of what indices is. When you tell somebody you are studying indices, it means you are studying the laws governing numbers we say are in index forms and the application of such laws to real life problems. Now, if you move ahead to answering the question what or when is a number said to be in index form, we are saying that if y is such a number, then it is in index form if we can write it as a raised to the power of x, where x can be called power, index, exponent, or logarithm, but this number a can be called the base. So let's not waste time on that. Let's move to the next question. Now, the next question I want to answer is, can one number have more than one index form? Can one number have more than one index form? The answer is a big yes. My answer to this question is yes. One number can have more than one index form. Now, let me give you an illustration of what we have just said here. If y is a number and we say we want to write the index form of y, then it will be a raised to the power x. This is the same as saying that y, if it is 25, can be written as 5 raised to the power of 2. Now, in this case, y will be 25, a will be 5, your a will be 5, and your x will be 2. Okay? So this is what it means when you write 25 as 5 raised to power 2. 5 raised to power 2 is now the index form of 25. That is what we mean by saying y equals a raised to power x is the index form of y. A raised to power x is the index form of y. The same way 5 raised to power 2 is the index form of 25. Now, if 25 can be written as 5 raised to power 2, these 2 here can be called index, exponent, power, or logarithm. Whereas this 5 here can be called the base, which is a. Now, I am asking a question. Can one number have more than one index form? The answer is yes. And why is that so? Let's see. Now, look at it carefully. A number like 64 can be written as 4 raised to power 3. And the same number 64 can be written as 2 raised to power 6. Okay? The same number 64 can be written as 8 raised to the power of 2. Now, can one number have more than one index form? The answer is yes. An example is having 64 written as 4 raised to power 3. When 64 is written as 4 raised to power 3, the base is a, the power, index, exponent, or logarithm is 3. When 64 is written as 2 raised to power 6, the base is 2, the power, index, exponent, or logarithm is 6. When 64 is written as 8 raised to power 2, the base is 8, the power, index, exponent, or logarithm is 2. Okay? And that answers that question. One number can have more than one index form. Let's look at another example of a number that has more than one index form. A number like 10,000 has more than one index form. If 10,000 is your y, you can write 10,000 as 100 raised to the power of 2. You can also write the same 10,000, one number, the same number as 10 raised to the power 4. So what are we saying? We are answering the question, can one number have more than one index form? The answer is yes. And these are clearly examples that one number can have more than one index form. If an index form means having a base raised to a power representing the number itself. That being said, let us now go to the next question. The next question is, what does the index form of a number mean? What does the index form of a number mean? What does the index form of a number mean? Now, if I have y equals a raised to the power x, the question is, what does it mean? Now, let's look at that example, 25 being your y and 25 being written as 5 raised to the power of 2. Now, please take note, the index form of a number simply means the number of times a base will be multiplied by itself to give the number. So look at it clearly. You will notice that 25 equals 5 raised to the power 2 because 25 is the same thing as 5 times 5. If you pick a number 5, which is the base, and multiply it by itself 2 times, it will give you 25. So if I have 100 written as 10 raised to the power 2, it means that 10 raised to the power 2 is 10 times 10. If I have 64 equals 4 raised to the power 3, 4 raised to the power 3, guys, means 4 multiplied by itself 3 times. If I have 64 written as 2 raised to the power 6, it means 2, the base, multiplying itself, of course, you guessed right, 6 times. Okay? If I have 64 written as 8 raised to the power 2, it means 8, the base will multiply itself 2 times. So what it means to be in index form is that the base must multiply itself the number of times equivalent to the power. Okay? So what does the index form of a number represent or mean? Now, that being said, if y is equal to a raised to the power x, it means that we can use what is called an expanded notation to say that y equals a raised to the power x means multiplying a by itself, x times. Now, please take note of this notation. We are going to be using it in our proof of the laws of indices. So if y is equal to a raised to the power x, a raised to the power x means a times ellipsis times a. That is the multiplication continues until the last a, and the last a will be the x a, meaning that multiplying a by itself x times will give you a raised to the power x. Now, let us now move over to the next item. The next item I want us to discuss is called the laws of indices. The laws of indices. So I want us to state the laws of indices. What are the laws of indices? Number 1, the laws of indices starts with a law we can call the multiplication law, or some people, I like calling it the addition law of powers, or the addition of power law, or the multiplication law, whichever way you want to call it. Please take note, the emphasis is not on the name you call the law, rather it is on the law itself and the meaning of that law. So I'm going to say a raised to power x times a raised to power, we could use small letter y, is equal to a raised to power x plus y. So that is what this law says. So if you have, the law simply says, if you have a number in index form multiplying another number in index form such that in both index forms the bases are the same, then the result is the same as taking one of the base raised to the sum of the two powers. Okay, so that is what the addition law is saying. Some textbooks will call it the multiplication law. Please don't get confused by the law or by its name. Get in line with the law itself. So let's go to what I would call the subtraction law, which some textbooks will call the division law. So I'm calling it the subtraction of power law, the subtraction law of powers. So what you would have here is that this law says, whereas the first law uses multiplication, this law is saying when you divide a number a raised to power x, a number in index form, by another number in index form such that their bases are the same, the result will give you the base raised to the power, the first power minus the second power. This law is called the subtraction law of powers. Some textbooks will call it the division law. Okay, so let's look at number 3. This law, I would call it the law of zero index, the zero index law. The zero index law. This law says that when a number is raised, when a base is raised to a zero power, the result will give you 1. Okay? The result of a raised to power 0 is 1. Number 4, the fourth law says, I will call this law the law of unity. I will call it the law of unity or unity law. This law says a raised to power 1 is a. That is, if you take a base raised to the power of 1, it will return the base. Okay, the same number a. So it means that you can look at these laws as follows. So look at this law. An example, e.g., of the first law we have just mentioned makes you see that 2 raised to power 3 times the same 2 raised to power 4 is 2 raised to power 3 plus 4. The same law implies that 10 raised to power 5 plus times 10 raised to power 2 will be 10 raised to power 5 plus 2. So once you see that the bases are the same, all you will have to do is add their power raised to that base. Okay, and add their powers in that base. Sorry. Now, example of the second law, if this were to be 2 raised to power 3 divided by 2 raised to power 4, the second law is saying that the result should be 2 raised to power 3 minus 4. And for the second, if it were to be 10 raised to power 5 divided by 10 raised to power 2, the second law is saying that your result should be equivalent to 10 raised to power 5 minus 2. That is what and how simple the law is. Now, if you come to the third law we have just stated here, the zero index law, you will take note of one thing. This law means that 100 raised to power 0, anything at all raised to power 0 is 1. 500 raised to power 0 is 1. 1 million raised to power 0 is 1. Anything at all, x raised to power 0 is 1. 5 raised to power 0 is 1. Anything raised to power 0 is 1. That is what that law is saying. Then, if you take an example of the unity law, the unity law is telling you 100 raised to power 1 is 100. Anything raised to the power of 1 is the same thing. 500 raised to power 1 is 500. 1 million raised to power 1, 1 million raised to power 1 is 1 million. Anything raised to itself will reproduce that thing. X raised to power 1 is x. And 5 raised to power 1 is 5. So these laws are just simple in interpretation, and we are going to be proving some or all of them. Let's go to law number 5. Let's go to law number 5. So law number 5 is the law I'm going to call the law of powers of powers. Okay, the power of power law. So we could or let's even take this law first, the law of negative index. Let's take the law of negative index first. Negative index, the law of negative index. This law says that when a base carries a negative power, the result is 1 over the base raised to the positive of that power. Okay, this law is called the law of negative index, and this law simply means that if you have 5 raised to power minus 6, the result is 1 all over 5 raised to power 6, the positive of this power. The law also means that if you have 2, the result is the same as 1 over 6 raised to power 2. The law means that if you have x raised to power minus n, the result will be 1 over x raised to power n. That is about this law, the law of negative index. Let's come to law number 6. Law number 6 can be called the law of powers of powers. Powers of powers. Okay? Now this law simply states that if you have a number raised to a given power, say x, and you raise that power, that is the number, that index form, to another power, say y, the result is the product of the two powers in that base. So that is what this law is all about. Look at it carefully. If I have a number 5 raised to power 3 and I now say 5 raised to power 3 square the result of 5 raised to power 3, my result will be 5 raised to power 3 times 2. If I have another number, say 4 raised to power 5, and I square this number, or I cube it, or I raise it to another power, let's say 4, then my result will be 4 raised to power 5 times 4. So if you take the power, if you put an index, a number is in index form, and you take another power of that same number, the result will be the product of those two numbers, the powers in that base. Okay, so it is as simple as that. Now let's move over to the next law. The next law I'm going to be looking at is this one. Okay, the next law I'm going to be looking at is the law of fractional index. The law of fractional index. The law of fractional index. Now this law simply tells you that if you have a base raised to a fraction, the result will be the root, the x root of that base. Okay, so a raised to power 1 over x is the x root of a. Now this law of fractional index, in this case, looking at this particular law, this law of fractional index can take two forms. So I'm going to call it 7a and 7b. Now 7a, if you look at 7a, you will notice that in 7a the law says that a raised to power 1 over x, the fraction here 1 over x has a numerator 1 and a denominator x. Now there is another version of this law. This law can actually be shown to be let me change this to y so that we are uniform with what we are saying. So if I have a raised to power x over y, then I would have my result by this law to be the wide root of a raised to power x. Okay, so this law, the law of fractional index, has two variations. In the first variation, you have 1 as the numerator of the power 1 over y, the fractional power 1 over y. In the second one, you have x as the numerator of the fractional power x over y. So when you have 1 over y as the fractional power of a, then the result you would get is the wide root of a. But when you have a raised to power x over y as the number in index form, the result is the same as the wide root of a all raised to the power x. Now let me show you an example of this law. In this example, take a look at this. If you have, for instance, 4 raised to power 1 over 2, this will be the square root of 4. Take note, when this denominator is 2, we don't put the 2 here because we are referring to the square root. However, if it were to be 4 raised to power 1 over 3, then I'm going to have the third root of 4. Please take note, when the denominator in the fractional index is 2, you don't put 2 in this root because it will be representing the square root. But if you have a number in the denominator of the fraction greater than 2, you have to put it there. So if I had this, let's say I had 10 raised to power 1 over 5, then this will be the fifth root of 10. Please take note, the 5 is within this v of the root. Okay, it must not be outside, because when it is outside, it means you are using it to multiply. So please take note of that. Now coming over to this other variant of the law, you will notice that I could have 10 raised to power 2 over 5. 10 raised to power 2 over 5. The difference between 10 raised to power 2 over 5 and 10 raised to power 1 over 5 is that in this one, you have 1 as the numerator in the fraction. You have 1 as the numerator in the fraction. You have 1 as the numerator in the fraction. But in this one, you have a number different from 1 as the numerator in the fraction. So here I'm going to have the fifth root of 10 all raised to power 2. And if it were to be 4 raised to power 5 over 3, I would have the third root of 4 all raised to the power of 5. So these two laws are called the laws of fractional index. Okay? Now, there is another law I will call the law of shared powers. I will call it the law of shared powers. The law of shared powers. Now, I usually would tell students that a good example of this law is your surname. Okay, let us see the law. So this law says that AB raised to power x is A raised to power x times B raised to power x. This law is synonymous to a scenario such as this. Take this to be two siblings. You could have this as two children in one house, born of the same parents. Let's say X is their surname. Now, if this boy answers Obi and this boy answers Chuku, let's say their father's name is Okay, then it means that the result will be Obi, Okay, and Chuku, Okay. This is one simple way I use in explaining this to my students. This law, called the law of shared powers, simply tells you that when you have two different numbers in product raised to a common power, then that power belongs to each of them. So A will carry the power. This power now looks like the surname of two children in one house. Please take note, the law applies to more than two numbers. We are just using two, for example. Now, look at the next law. This law here has a variant, okay? This law has a variant. Let's look at another variant, the B part. A over B raised to power x. What if this is not a product, rather it was a fraction? The law is still applicable. It will still carry A raised to power x all over B raised to power x. Okay? So this law is called the law of shared powers. Now, in my next class on indices, I am going to be proving these laws. And that will be tomorrow evening. Okay? Tomorrow evening, 9 o'clock, I'm going to be proving these laws. Please look at these laws one after the other, and I'm going to be seeing you in my next class, being 9 o'clock tomorrow, Saturday. So we are going to be proving each of the laws of indices and applying them to problems. Thank you very much and good night.